Hello everyone! Welcome back to my YouTube channel. It's me again, your teacher Marlene Nuno, and I'm going to start our discussion for the quarter 4, which focus about the trigonometry. And the first topic that I'm going to discuss is about the 6th trigonometric function. Let us start. Trigonometry is a branch of mathematics that studies relationships involving lengths and angles of triangles. It is also derived from Greek words tri, which means 3, gonia, which means angle, and metron, which means to measure. Now let us recall the different parts of right triangle. So in the figure, we have right triangle BCA with right angle at angle C. So recall that the hypotenuse is the longest side of the triangle. It is always opposite the right angle. So it is our segment AB. Then we have two legs, which are the shorter sides. These are always opposite the smaller angles. So these are side BC and side AC. Now remember, we will encounter the terms opposite sides, and it all depends on the reference angle. Now in the figure, we have triangle BCA, wherein we have the symbols theta and beta. So the opposite in relation to angle A or angle theta is side BC. Otherwise, the opposite, the angle B or angle beta, is side AC. And also, you will encounter the term adjacent sides, and it all depends also on the reference angle. So in the figure, adjacent in relation to angle A or angle theta is side AC. And adjacent to angle B or angle beta is our side BC. And of course, the hypotenuse, which is referring to side AB, remains the same, for it is always opposite side of the right angle. Now let us have the 6th trigonometric function. The 3 primary trigonometric functions are the sine, which is in symbol SIN. We also have the cosine, COS is its symbol, and the tangent, wherein we're going to use symbol TAN. The 3 secondary trigonometric functions, which are just the reciprocal of the primary, are the cosecant, which are going to use CSC, the secant, we're going to use SEC, and the cotangent, wherein we're going to use COT, respectively. So meaning, the reciprocal of sine is the cosecant. The reciprocal of cosine is the secant. And the reciprocal of tangent is the cotangent. Now, let me introduce to you the 6th trigonometric function. The acronym SOH-CAH-TOA is used to easily memorize the trigonometric function. And I'm going to show you how will you use this. Now let us have first our illustration of right triangle BCA. So at this point, our reference angle is theta. To describe our sine, it is opposite side over the hypotenuse, and it is referring to our SOH in acronym. S stands for sine, O stands for the opposite side, and H for the hypotenuse. So in the figure, the opposite of our theta is represented as A units, wherein the hypotenuse is C units. So the value is A over C. For our cosine theta, where it is described as adjacent side over the hypotenuse, it is now referring to the acronym CAH. C stands for the cosine, A for the adjacent side, and H for the hypotenuse. So again, in the figure, the adjacent side of theta is B, and the hypotenuse is C. So the value of the cosine theta is represented as B over C. Then the other one is the tangent theta, where it is described as opposite side over the adjacent side. It is now in the acronym TOA. T stands for the tangent, O for the opposite side, and A for the adjacent side. So in the figure, the opposite side of our tangent theta is A, the adjacent side is B. So the value of tangent theta is A over B. For its reciprocal, we can easily find our secondary trigonometric function by taking its reciprocals. For sine theta, the reciprocal is cosecant theta. So it is described as hypotenuse over the opposite side. So we have the value C over A. Similarly, the reciprocal of cosine theta is the secant theta, where it is described as hypotenuse over the adjacent side. So we have the hypotenuse is C and the adjacent side is B. So secant theta is C over B. And lastly, we have cotangent theta, which is the reciprocal of tangent theta. It is described as adjacent side over the opposite side. So the value of the cotangent theta is B over A. Now let me show you some examples in finding the sixth trigonometric function. So in the figure, we have right triangle BCA, wherein our reference angle is theta. Then the length of AC is 24, the length of BC is 10, and the hypotenuse AB is 26. Now let us start with sine theta, which described as opposite side over the hypotenuse. So the opposite of theta is 10 over the hypotenuse, which is 26. So 10 over 26 is simplified as 5 over 13. For our cosine theta, which described as adjacent side over the hypotenuse, so the adjacent to theta is 24 and the hypotenuse is 26. And this is simplified into 12 over 13. Then we have tangent theta, which describes as opposite side over the adjacent side. So the opposite of theta is 10 and its adjacent is 24. So 10 over 24 is simplified into 5 over 12. For its reciprocal, we have cosecant theta, which is reciprocal of sine theta. So describes as hypotenuse over the opposite side. So we have 26 over 10 is now simplified to 13 over 5. Similarly, the reciprocal of cosine is secant. So we have hypotenuse over the adjacent side is equal to 26 over 24 or simply 13 over 12. And the reciprocal of tangent theta is cotangent theta, wherein we have hypotenuse over the opposite side. So we have 24 over 10 is simplified to 12 over 5. Now let me give you another example. So find the value of the sixth trigonometric function of the angle beta. So opposite of our beta is 4 units. Then we have adjacent is 2 square root of 5. And our hypotenuse is 6 units. So sine beta, which described as opposite side over the hypotenuse, is equal to 4 over 6 or simplified to 2/3. Cosine beta, which is adjacent side over the hypotenuse, is 2 square root of 5 over 6, wherein 2 over 6 is simplified to 1/3. So we have square root of 5 over 3. And for tangent beta, which is the opposite side over the adjacent side, so we have 4 over 2 square root of 5. Then since we have radical in the denominator, to eliminate this, we have to multiply 2 square root of 5 over the square root of 5. So we have the answer as 2 square root of 5 over 5 because we have to divide 4 by 2. Now, for its reciprocal, cotangent beta is the same as 2 square root of 5 over 4, wherein 2 over 4 is the same as 1/2. So the answer is square root of 5 over 2. Then, the reciprocal of cosine beta is secant beta, wherein the value will be hypotenuse 6 over the adjacent 2 square root of 5. Then rationalize by multiplying it to square root of 5 over the square root of 5. So 6 over 2 is equal to 3 times the square root of 5. So we have 3 square root of 5 over the square root of 5 times the square root of 5, which is the square root of 25, or simply 5. So 3 square root of 5 over 5 is the final answer. And we have the reciprocal of sine beta is cosecant beta, wherein we have the hypotenuse, which is 6, and the opposite is 4. So 6 over 4 is simplified to 3/2. Let me give you another example. So given the figure below, find the values of the sixth trigonometric function. So we have this figure. Our reference angle is theta. Opposite of theta is square root of 3. The adjacent is 2 units. And the hypotenuse is square root of 7. So for sine theta, which is the opposite over the hypotenuse, so square root of 3 over the square root of 7. So since we have square root of 7 in the denominator, let us rationalize by multiplying this to square root of 7 over the square root of 7. Then multiply the numerators. Square root of 3 times square root of 7 is the square root of 21, and the square root of 7 times the square root of 7 is the square root of 49, or 7. For its reciprocal, which is now cosecant theta, we have the hypotenuse, square root of 7, over the opposite, which is square root of 3. Then let us rationalize by multiplying to square root of 3 over the square root of 3. And then multiply the numerators over the denominators. So square root of 7 times square root of 3 is the square root of 21. And the square root of 3 times the square root of 3 is 3. So square root of 21 over 3 is the simplest form. For our cosine theta, we have the adjacent, which is 2, over the hypotenuse, which is square root of 7. Then let us rationalize by multiplying it to square root of 7 over the square root of 7. So 2 times the square root of 7 is 2 square root of 7 over the denominators. The square root of 7 times the square root of 7 is 7. So 2 square root of 7 over 7 is the answer. Now for its reciprocal, we have secant theta, which is the hypotenuse over the adjacent. So square root of 7 over 2. And this is in simplest form already. For our tangent theta, which is the opposite, square root of 3 over the adjacent 2. So this is in simplest form already. So square root of 3 over 2 is the value. While its reciprocal, which is cotangent theta, which is, we have the adjacent 2 over the opposite, which is square root of 3. Then let us rationalize by multiplying it to square root of 3 over the square root of 3. Then multiply the numerators over the denominators. 2 square root of 3 over 3. Well, I hope you learned in our discussions. So try to remember the SOH-CAH-TOA, which will be helpful in writing the 6 trigonometric functions. So always start with the primary trigonometric function and then take its reciprocal for its secondary trigonometric function. Now it's time for me to check how well do you know. So try to answer this. The following are the secondary trigonometric function except, is it A, cosine, B, cotangent, C, secant, or D, cosecant? Thank you for watching. God bless everyone.